Ettore from University of Torino.
Thank you very much. So thanks a lot to the organizers for inviting me here. I'm delighted to have the possibility to present to you a bit of our work we did in cooperation with MIT, with Dr. Botterund, and also with Enel Foundation, that is the research branch of Enel, that is the largest Italian utility for electricity, and I think one of the two largest utilities in the EU for electricity. We did a work together trying to figure out which can be the role played by electricity in the energy transition. This is a general context, and we try to apply this context, this concept to the electrification of our country, of Italy, up to 2050. So I will try, to start with a rationale and the objective of our study with very well-known concept. I pointed out only three. Energy accounts for 2/3 of the global greenhouse gases emission, so is an important issue. 90% of air pollution is due to the fossil fuel combustion, and there is another important part that is about 1 billion of people do not have yet, nowadays, access to electricity. So we are a problem that is basically related to fossil fuels. We need a transition from fossil fuels to something else for three reasons: for GHG emissions, for pollutions, and also for the depletion of fossil resources. In the Mediterranean area, we have gas and oil for 30, 40, 70 years, not more. Given this and keeping this as an idea on the background, we can have an idea of the total primary energy supply worldwide, and you see the total energy supply worldwide is heavily relying on fossil fuels, more than 80%. As an effect of that, the CO2 emission worldwide related to the energy are the largest share, around 60%. And as an effect of this, we have a bunch of problems in terms of environmental impacts, and just some numbers about the increase of the land and ocean surface temperature from 1880 to 2012, something around 1 degree Celsius, a little bit less. The reduction on the Arctic Sea extension, that is around from 3.5 to 4%, and the global mean level of the sea that has been increased more or less of 20 centimeters. So this is the situation that we are facing, and from the point of view of GHG and so of the global warming. From the point of view of the pollution, we can immediately spot from this picture that energy-related problems are huge, because if you see more or less all the pollutants, with the only exception of ammonia, are due to the energy sector. Sulfur dioxide, nitrogen oxides, PMs, carbon monoxide, and volatile organic compounds are highly related to the energy industry. So to act on this will be crucial for assuring the sustainability of our planet in the future. The air pollution is bad, of course, but it's bad because can have huge impacts also in terms of especially in terms of the health of the biological system and also of the humans as well. If you see here, we have more or less 7 million of deaths that every year are caused by the pollution. They are divided into different shares in different countries. So China, India have a predominant role, especially inside the houses, and China, especially outdoor. North America is not very huge, you see, NAM, and European Union is not that huge, but worldwide is an issue, is a problem. Focusing to Italy, this is a study that has been done by a governmental agency that is strictly connected with the Ministry of the Health. And you see that in 2010, we have 35,000 premature deaths due to the pollution in our country. And you see they are pretty much concentrated in the industrial areas. This is Milan, this is Turin, this is Milan, this is around Rome and around Naples. So there were the two main, the two first issues that I was listing. The third one is energy poverty. We said 1 billion of people do not have access to electricity. And there is a large share of the world population, around 13%, that have no full electricity access, maybe for technological or infrastructural gaps, or even for problems related with affordability. They cannot afford to pay for electricity and energy in general. So 15% of the developed countries' population suffers from energy poverty. That happens also in Europe, in Germany, in Italy, in France, that you wouldn't expect. Okay, there is a discussion we can do about the fact that the people that has no access can reach them with new paradigms, not related to the large infrastructure, but the distributed generation and so forth. That is an issue that is worth to discuss, but we have no time to do that here. Also here you see the energy inequality. If you look how the energy consumption is shared in the population of different areas in the world, and you consider the very typical Gini index for doing that, in which perfect equality is 0, perfect inequality is 1, everybody has the same share if 0, and only 1 has the whole share if is 1, you see that at the world level, the index is 0.5. In the European Union is 0.22. So there is, let's say, an issue of fairness also in the energy exploitation by the population. Okay, so we said that, those are the problems, and we can try to think to the energy transition done through electrification. And what we thought, and we tried to think in this project and to apply to Italy as a typical study case, is the idea to implement what we call the electricity triangle. And the idea is we face energy transition with an electricity triangle in which we have electricity generation that is directly generated from renewable energy sources as electricity. We have no thermodynamical cycles in between, and this is one of the vertex of this triangle. And then we can use electricity as energy vector instead of using other commodities. We can transfer energy even across long distances in terms of electricity, not using gas or oil. You know the project that the Chinese are doing to make available high voltage DC lines, 1,500 kilovolts, that are capable of transferring tens of gigawatts, 10, 15 gigawatts, over distances of 5,000, 6,000 kilometers. And so you see, this is more or less distances that are close to the pipeline for gas that from Russia can reach Europe or this. So electricity as an energy vector directly, and then the electrification of the final uses. I can put a lot of electricity in the final uses, in the transport sector with electric vehicles, in residential uses with heat pumps, and also in the industry I can use arc furnace oven instead of the traditional one. This is basically the paradigm. This can be done, but I have not so much time to discuss about that, according to different paradigms. One is the global energy interconnection, so it's large-scale infrastructure with high rated power, renewable power plants concentrated around the North Pole or in Africa, and then a worldwide ultra-high voltage transmission system, what we call the super grids, or can be done the other way around with the smart grids, so distributed, small rated power generation facilities very close to the consumption in the, let's say, smart city environment, for example. Okay, that was the idea. So we tried to apply this triangle to Italy and see what happens. In our studies, we had basically three main goals, three main objectives. Discuss electrification as a major option for implementing energy transition in Italy, considering the present situation and trying to project what could be the situation in 2020, 30, and 50. The second one is to integrate a multi-focus perspective in which we analyze both the demand for different sectors, basically industry, residential, and transportation, with the supply side, that is the potential of production of electricity by renewable energy sources in our country. And then the last point is to try to make a quantitative assessment of the benefits, if any, but we found benefits, of the benefits of this approach through a set of KPIs that can provide a quantitative assessment of the impacts of this possible way to go toward an energy transition. Some ideas about the methodology. Okay, we put together different pieces. So we started with some interviews to the key players in the sector to get the feeling about which are the problems, the perspective, and even the expected benefits from the electrification. And we have a detailed report about that. Then we tried to match the generation for renewable energy sources with the three sectors I was mentioning, residential, industrial, and transportation, and to see how we can match them together in Italy. And based on that, we build with these three different milestone years, starting from now, going to 2050, some scenarios to which we applied a set of KPIs in different, with different dimensions, energy, economy, society, and environment, to assess the impacts and hopefully the benefits of this proposed approach. This is basically, again, what I was explaining. We have focus on renewables, focus on building, focus of industry, and focus on transport. This one has been followed mainly by MIT. This two has been done by Politecnico di Torino. This one was the contribution for Enel. We put them together to build the scenarios and to run the impact analysis. We were saying that it is important to provide a quantitative assessment of the benefits or the impacts of this choice. And for doing that, basically, we designed, pretty obvious, well, but we considered 47 different indicators that are grouped in 4 different dimensions I was mentioning before. Some are related to the environment, some are properly energy indicator, some are related to economics, and some to the social impacts. Okay, I will not comment on each of that. It will take a lot of time, but just to give you a feeling about the indicators we have. These are the first set of indicators, some of the first set of indicators related to energy. And so, for example, we try to track over the different points in time, which is the ratio between the renewables for electricity and the electricity that is produced from fossil fuels, the contribution of electricity to the variation of total prime energy supplies, or the share of electrification in the country, or also the contribution of electrification to the national energy dependency. You know that in Europe we are highly energy dependent from abroad. If you consider EU, the European Union as a whole, the dependencies from abroad is 50%. If you consider Italy, it's 80-something, 82%. So this is also a relevant problem. And okay, the variation of per capita consumption over the year, a set of possible KPIs for energy. Then we consider different KPIs for, of course, environment. So CO2 emission from electricity generation, from final consumption, the total CO2 emission, and this is in terms of GHG. And then we consider some indicators related to the pollutants that we inject into the atmosphere. So the second dimension for the KPIs. The third dimension is relating more to how the economy will evolve if we go in this direction of electrifying the country. And so some typical KPIs like energy intensity, the variation of energy intensity due to electrification, because usually the electricity technologies are more efficient. The carbon intensity, how the carbon intensity is changing, the weighted LCOE, and the contribution of renewables to the variation, that is hopefully a reduction of LCOE. Last but not least are the social impacts that we consider with respect to two different sub-dimensions. One is the healthcare. If I reduce pollution, I will have savings in terms of the expenditure for health services. We can see some numbers afterward. And then we have a set of social indicators that are basically related to the affordability. I can reduce the price of electricity, so the impact, if you want, of the bill, energy bill on an average Italian family will be reduced. Okay, very briefly, there is a long discussion. We are going to present a report in the next 2 months. So what I'm telling to you is just a little bit preliminary, but we spotted, speaking with the manufacturers, with the regulators, with the research institutions, some possible pros and cons related to the electrification. The good points are the increase of energy efficiency. Most of people think that is a good thing. You know, there is this idea of rebound effect from Jevon's time that maybe says that the consumption can even be increased. But okay, the player said energy efficiency is very good. Renewable penetration increase, decarbonization, and even new job position that can be created. The barriers to implement the electrification in our country are mostly related to the habits of the customers. They don't like electric vehicles because they are scared not to go to the final destination but to stop before. The high initial investment cost, high electricity and gas price ratio. Now the ratio between the price of electricity and the gas is 3:1 in Italy, so it's discouraging electrification. Inertia of the existing infrastructure, a lock-in of, let's say, not electric technologies, and the lack of adequate regulation. Okay, this is the focuses, and I will try to be a little bit quick on these. The first focus is about the renewables. We studied that in detail, but I will not speak about this because Mehdi will provide a presentation specifically on that a little bit later, so I leave to him the pleasure to explain what we did in terms of renewables. I say something briefly about the other two focuses, the other three focuses, that is residential, industrial, and transport. So we tried to implement a methodology in which basically the idea was to make the optimization of the Italian system based on the minimization of the global cost for CO2 equivalent avoided in the residential building. Consider 30 different typologies of buildings, considering 5 different geographical areas. Of course, to it, Naples is different than to it in Turin because the temperatures are very different. Italy is, from the geographical point of view, is done like that. And different ages of the houses. If they are older, the insulation is lower. If they are more recent, the insulation is higher. Okay, doing this kind of analysis, we could take out an index that is the energy efficiency indices for all the buildings, residential building in Italy, making a reasonable model of what is presently built in our country. And from that, we got the total consumption and the electrification potential for the residential buildings. We consider different scenarios, and we choose basically one of these scenarios in which the important point is to see that the renovation rate of the buildings in Italy is 1.8% per year. And so in this case, if I make a remodeling of my apartment or of my building, I can introduce electricity technologies instead of the traditional one. Looking to this sector, we were able, with this model that I briefly introduced, to forecast the number of units for space heating and for water heating in the residential buildings up to 2050. And what you can see here is the heat pumps are going to play a major role with respect to the gas boiler that will be still there in 2050, but much less than they were or they are nowadays. Okay, the same for water heating. So if you have a look to what we expect for the final energy consumption in our country out to 2050 is Oil is going to disappear around 2025 or so. Electricity is going to increase. Biomass will be still there, and natural gas will be highly decreasing, even though, as we were saying, will be still there. Here there are different scenarios we simulated for the sensitivity of the tariffs. I mean, if you provide special incentives, as we do, if you use electric heating, for example, if you use heat pumps, you have a special tariff for paying electricity. And you have a flat price for electricity that does not increase with the quantity. But the sensitivity of these different mechanism for fixing the price if you use electricity is not that impacting. What is really impacting is the renovation rate of the houses. So one policy, good policy suggestion is to provide incentives to remodel, to renew the buildings, and if you go from 1.8 to 2.5, you see that the electrification goes from 43% to 66%. So that could be a very good driver to push in this direction. Okay, for the industry, we took a methodology in which basically the idea was to make simulation based on the levelized cost of heat for each time step we considered and for each industrial subsector and for different temperature level. We did a model to compute the heat production achieved by different technologies, and based on that, how we could update the stock with a least cost solution. Potential of electrification basically was studied based on services, mechanical work, refrigeration, heating, and lighting. We consider different technologies from electricity and conventional gas, oil, and coal and oil technology as competitors. And we consider, of course, the capital cost, the learning curves, conversion efficiency, and so forth. Based on that, we derived a scenario that has been put together with all the other sectors. But the idea is that industry electrification has not a very high margin because the industry is already quite electrified in this country. And if you look to the comparison with different countries, you see that Italy is among the most electrified countries for the industrial sector. So if you compare even with Germany, if you compare with United States, and if you compare with the average in Europe, in Italy, industry is already pretty much electrified. So the space we have to improve is not that large. Okay, low temperature heat pumps are more convenient, while high temperature heat pumps are not convenient from the economic point of view. If you look to these slides, you have the levelized cost of heat if you use electrical technologies for different temperatures. And you see that if you are considering low, medium temperature, this is convenient. If you consider high temperature, it's not, because this blue dashed rectangle provides the cost if we do the same service in terms of heat provision with fossil fuel technologies. Okay, just a brief notion that is something we can consider as a plus. If I'm an industry, I can have let's say, provide the services I need through electricity. I can do demand-side response. I can be much more flexible. And so that can provide an additional benefits that I can monetize in my business. And we can avoid investment in peak generation, so we can provide the capacity value. We can provide the reserve for the TSO in terms of flexibility. And so this is another value. And then we can balance supply and demand locally, maybe helping solving congestion, so we have even a network value for this. Well, on the transport, we did a similar analysis. We do the consumption model of various kinds of vehicles, considering aerodynamical internal frictions, efficiency, resistance proportional to mass and inertial load, and we based the analysis on the stock of vehicles and other constraints. We try to take out the total consumption of different energy commodities. We did this under a set of pretty obvious assumptions. Environmental policy requires a strong reduction in emission of pollutants and CO2 in Europe. The cost of batteries and electric powertrain is going to decrease by 60 and 25% respectively from now to 2050. Energy efficiency of energy conversion and powertrain in electric vehicles can increase, but not so much because they are already pretty efficient. So we assumed 5% to 2050. City buses are considered to be 100% electric. Penetration of electric vehicles in LCV, light car vehicle sector, is considered similar to what assumed for passengers. Electrification of long-distance heavy vehicles, like coaches and trucks, can reach a penetration of 20% and 25% in 2050. Electrification for air and water transportation is negligible. For water transportation, they are thinking about what they call cold ironing. That means that when the ship is on the port, they are connected with electrical supply, don't use the internal engines. But for transportation ships, I think they are moving toward gas, and air transportation is difficult to think to be converted into electricity motors in the short term. Okay, what we got out of this is the energy consumption from transport is reduced by 49% and the road transport energy by 60% in 2050. Total road service remain constant, even if we have a slight reduction in the population. We expect to have 8.5% less in Italy in 2050 with respect to now. Electrification road transport increases the efficiency of use of energy by 136% in 2050. Okay, here you have some idea in which you see, for example, for the millions of cars that the share of electricity plus hydrogen in 2050 will be huge, while the fossil fuel will be a small share of them. And also that thanks to the introduction of the electric technologies that are more efficient, you can get energy saving of almost 600 petajoule in 2050, or at least this is what we expect. Just to conclude, I can provide to you some key highlights of what we got out of this study. So this is, let's say, a summary of the main findings. Electricity triangle, so our view for electrifying the country and for doing the energy transition, can be an effective solution for the environment. Almost 70% CO2 emission reduction in 2050. And the contribution to this reduction of electrification is around 80%. Because, of course, the reduction in the emission is not only due to electrification, that plays the major role, also to the, let's say, increase of the efficiency of the traditional gas and oil technology during the following years. But, okay, the biggest share is due to electricity. Health, we estimated that in terms of healthcare, productivity, and life expenditure, healthcare is the cost to the health and service for providing healthcare to the people that is affected by diseases related to the pollution. Productivity is the number of working days that are lost, and life expenditure are the cost of the mortality. We estimated almost 800 billions of euros of economic savings. Also, we estimated that for the energy expenditure of the Italian family, that will be a reduction of around 40%. Now, if we compare with the average income, the expenditure for energy in Italy are around 10%. And we can save another 35–40% on this value. This is achieved, these 3 points that are, I would say, impressive, are achieved through different ways. The first one is on the supply side, high penetration of renewables. We estimated, or the estimation was to have 85% in 2050. with a key role for the solar. We are the country of sun, as somebody says, so okay. On the demand side, to a relevant penetration of electricity in final uses, up to 45% in 2050. From a sectorial point of view, residential, building, and transport sector are the largest electrification growth potentials. From 2015 to 2050, we can say from 50% to from 15% to 53%, and from 3% to 38%, while industry can only have a marginal improvement for the reason I was mentioning before. The idea that electricity can effectively contribute to decarbonization is seen over here, in which you have the total sector CO2 emission that are estimated by our sectorial studies I briefly introduced, and you see 2050 minus 67%. You can even see the trend over the years. The electrification can effectively contribute to decarbonization, because you see in this picture over here, you see that the whole is the contribution, is the decrease in CO2 emissions, and the blue one is the contribution of electricity, while the other one is, well, in this year is the phase out of coal, and here is the increase of the efficiency of traditional technologies. And also the electrification in terms of share of electricity in the total final energy consumption will reach, we are more or less 16%, we will be 23% 2030 and 45% in 2050, according our estimation. Let's look what we can do for improve people's health. And you see the reduction of PM, pretty impressive. Again, this is shared by the different sectors. So you see for building, you see for industry, and you see for transport. Again, the same in terms of pollution, NOx. And what you can see here is the cumulative health cost saving that are not very huge in 2022, and they rise up to almost 800 billions of euros. That is quite a lot in 2050. Last, the issues of affordability. You can see here, which is the reduction of household energy expenditure, considering a constant income. So you see that the reduction will reach minus 38% in 2050, and again, the share of this reduction due to the electrification is pretty important. Okay, just to have a look, the penetration of electricity in the different sectors, building, industry, and transport. And you see, what is interesting to see, if you compare the present situation with the future situation, is that industry is kept more or less constant, while you see that in building, from 6 you go to 20, and in transport you go from 1 to 12%. So there is a comparatively a very high. Electricity role in total final consumption reduction. So you see again, which is the role of the electrification divided by the three sectors, transportation, industry, and building, in the reduction of total final consumption. Last, this is the assessment of the importance of electrification in making our country more resilient or less dependent of geopolitical issues in terms of importing energy. And you see in 2050, the dependency of the country, as I was saying, now is 82%, will be reduced basically of 36%. Again, the largest share is due to electricity. I will not comment in detail this, but we did an analysis. We compared the scenarios we built with different scenarios you can see listed here. And we compared our indices with the indices provided by other scenarios, and we see that more or less our work can fit, even though there are, of course, differences. That's it. Thank you very much.
Thank you, Ettore. Any questions?
kind of generic scenarios, or did you, let's say, optimize the future optimal size of a heat pump depending on the...
The idea is to optimize the cost of avoided CO2 according to different scenarios.
Okay.
So based on that and based on the consistency of the present stock of buildings we have in Italy, having done an analysis of all the typology, we could make that assessment.
And just a small other one, district heating and cooling does not play a role yet, or also in the future when having in mind waste combustion?
That have been considered in terms of, well, they are not properly biofuels, but they have been put together. For example, we consider the competition between heat pumps and boiler based on wood and biofuels and waste.
Okay.
So in the model they are considered.
Just wondering about some of your assumptions relating to grid stability. You know, your very high penetration rate of 82% of renewables in 2050. Did you model any grid stability issues, or if not, what were your assumptions?
In this study, not. This is another story. We are working presently with Terna. Terna is the Italian TSO, and ENSOI, that is the association of the European TSOs, in doing modeling to assess how can be the stability of the network, European network, with an increased penetration of renewables. This has not been considered here because this is a scenario analysis, but we are working on that. Actually, if you consider, they have the 10-year development plan of ENSOI for all the European network. If you consider what they forecast up to 2035, we did the analysis, and the system, let's say, could survive, should be still frequency stable for that. 45% is a lot, but the idea is that we can study. Actually, we are doing with the Aachen University a project that is called 100% renewables. So it's the idea to make a network that can accommodate 100% of renewables using a proper control of the converters. This is another story. I mean, we can discuss the technical details. Here in this project we assume that that is feasible, and maybe it's really feasible from the technical point of view.
Steve, have one more quick question? Yeah.
Yeah, one question about this, the health benefits, because that's quite a remarkable high number. Was it like 800 billion euros?
Yeah.
Was that from now to 2050?
Yes, it's the cumulative.
Yeah,
it's
so
the cumulative,
like
yeah.
cumulative.
Yeah, so I mean, if you split, it's not that, it's less impressive. It's impressive, but a little bit less.
Yeah, but it's still impressive. I just, that it's interesting later to look at how that compares to other country studies of similar electrification studies than in other countries, because it's say if that is a correct number, that might be the main benefit of electrification, considering the enormous improvement in health, more than the electricity bill.
While we were doing this study, there was a study in parallel done by Euroelectrics in Brussels. Now, you know the association. And they did a similar study, which we have been involved because Enel is partner, of course, of Euroelectric, so they were following the two studies, and we use Italy one of the case study. So what we did has been somehow confronting the harmonized in this analysis with what they got from Euroelectrics, and we are not too far away.
No, that's interesting. Thank you.
Okay, great. Thank you, Ettore.
Thank you. Thank you very much.